Hello class, this is Mr. Lehman. Today we're going to talk about Toxins Lesson 4, which is all about the conservation of mass. And so what we have here, I have an equation shown. Calcium carbonate will decompose, will break down if it's heated to produce calcium oxide solid and also carbon dioxide gas. And so what the law of conservation of mass says is if I start out, let's say, with 50 grams of calcium carbonate, and I heat it up, and it starts to break down, after it all breaks down, then how much should it weigh? Well, if I know, if I make 28 grams of this, and a lot of gas is given off, then by default I know that I must have had 22 grams of gas as well. How do I know that? How do I know it? Because if I start out with 50 grams of material, according to a law of conservation of mass, my 50 grams of material should, or will always produce 50 grams of products. So if I produce 28 grams of a solid, then I know by default that I must have produced 22 grams of the gas. See another application of this, and here once again what I just said, the mass of the reactants, what's on the left side, is always going to be equal to the mass of the products, what you produce on the right side. And that's because atoms are never created or destroyed during chemical reactions. So we keep the same number of each type of atom present, and they simply rearrange themselves. They form new chemical bonds and rearrange to form new things. And so if we're not destroying atoms, or we're not creating them, then obviously it's going to stay the same mass. So another equation here, let's say this time we're going to take some hydrochloric acid, it's dissolved in water, and let's say we add 50 grams of this substance. We add it to a beaker. And then we take a chunk of magnesium metal. And we throw it into the beaker as well. There's a chemical reaction. There's a chemical reaction taking place. When we're done, it only weighs, let's say, 79.5 grams. What happened? Well, if we mix together 50 grams of one material and 30 grams of another, that's 80 grams of stuff. We should end up with 80 grams of stuff as well. We didn't. We ended up a little bit less, 79.5. The question is, why? What happened? And so what it comes down to is we produced a gas, a very light gas. This gas, hydrogen gas, is the least dense of all the gases on Earth. So as we had little bubbles of CO2, or excuse me, as we had little bubbles of H2, hydrogen gas forming, those bubbles are so light that they rose to the surface, and when they popped, all this hydrogen gas left and entered the atmosphere. And so if we're left with only 79.5 grams of stuff, that's telling me that we must have produced a half gram of hydrogen gas, which is no longer around to measure. So a half plus 79.5 is equal to 80 grams, which is what we should have remaining. So watch out when you produce gases, unless you have a sealed container, which you shouldn't seal a container because then you're asking for an explosion. If you have, so say, a flexible container, like you put this all into a Ziploc bag, unless you're able to seal it off like that, you're always going to lose a little bit of mass if you're producing a gas. Alright, hope this helped.